Hi guys, I hope that you are doing well. Welcome to part 5 of our series. So I just want to make sure that you do understand what we are going to do today. So we are going to deal with the first principle derivation. This video was actually requested by someone who said that I'm currently struggling with it. I don't understand why are we using the first principle and so forth for our derivative. So I think this one will be the best video for you guys, more especially if you are doing your grade 12. So the first thing that I'm going to do is to start with the first principle for this particular function here. So when they say that you have to derive something or, determine f prime x from a from the first principle of a given function, you have to think about the following. So if you have your f of x, which is equals to x squared, the plus of x, you can actually derive this one time and say f prime is equals to, then 2 times x will be 2, and x, and then 2 minus 1. The plus of 1 times x, that will be x, then 1 minus 1. This is actually the derivative for this 2x, and then 1 we won't show 1 because it's actually invisible. The plus of x to the exponent 0, 1 minus 1. Anything to the exponent 0 will equal 1. This is our answer for f prime x. So the thing is that they are not looking for something like this. They are looking for the limits. So if they are looking for the limits, give them what they need. Or when they are looking for the first principle, you have to give them what they want. So with that, I'm just going to erase everything and give you the solution for it. So again, I'm going to start with f of x, which is equals to x squared, the plus of x. So they want you to use this particular function here, which is equals to the limit as h approaches 0, and that will be f of x plus h, and then the minus of the function, okay, all over h. This is the function. So the thing is that everywhere where we see x squared or x, we substitute our x plus h. So that implies that we are going to say the limit as h approaches 0, and then x squared will be the following: x, the plus of h, and then squared, and then where there is x, plus x, the plus of h, and then minus f of x, and f of x is the entire function, so that will be minus the entire function in the bracket, okay, in the bracket h, right? So I should start using small fonts. So what I'm going to do now is to continue with our function. So I'm going to erase everything so that we can reuse the space up here. So this is equals to what? Let's try to expand this first, and then that this will be x, the plus of h, x, the plus of h, which is equals to x times x. So we'll say that sorry, the limit as h approaches 0 is equals to, or is, x squared plus xh, and then plus h times x will be xh, and then h and h will, like h times h, will give us the plus of h squared plus x h, or x plus h, and also the given function, right? So with the function, you have to make sure that you multiply everything by negative negative outside. This will be negative x squared. Let me write it down here, the other x, which is negative x, all over h, right? So I'm going to erase everything. I'm sorry that I did not actually present that part clearly because of the space, but I just wanna rewrite everything up here to say the limit as h approaches 0, right? So I'm going to write everything the way it is for the presentation. So x squared, the plus of xh, the plus of xh, the plus of h squared, and then the plus of x plus h minus x squared minus x all over or divide by h. Okay, so this means that we have our entire expression here, and we can see that this minus x squared and the positive x squared will cancel each other. The minus x here and the plus x here will cancel each other as well, and then this and this will give us 2xh. So this means that the limit of h approaching 0 will be 2hx, right, for this one and this one, and then plus h squared, and then plus h all over h, right? So this is what we have at the moment. I'm going to erase the entire space so that we can reuse the space. So now we have to take the common factor of h, because you can see that we have the common factor in our expression. This implies that the limit as h approaches 0 is h is to 2x. This one will be plus h, and then the plus of 1 all over h. If we multiply everything by h, we should get this. That's actually the goal. So now you should make sure that you have the division. So this and this will cancel each other. I really prefer using colors. So this and this will cancel each other, meaning that you are going to have what? You are going to have what? The limit as h approaches 0, which is 2x plus h, then plus 1, right? So this means that as h approaches 0, then this will imply or equal 2x, and then 0 will be nothing, and then we are going to have 2x plus 1. So meaning that our f prime will equal 2x plus 1. This is your solution, so you can get your 7 marks out of that. Hope that you do understand everything. I'm sorry about the colors. Please comment if you don't really like the colors, then I'll definitely change it. So I will continue with our second equation that said that determine f prime, which is the derivative of the following equation, right? This is actually the simplest of all, although they will give you a 3 or 3 marks. This is actually the simplest of them all. I'll definitely use this space for it. So okay, we have f of x, which is equals to 2x and then to the exponent 5, 3x exponent 4, the plus of 8x. So meaning that if we derive this particular equation, we are going to get 5 times 2, which is 10, minus 1 up here. It means that this will be x maybe, okay, let's say 5 minus 1 up there, then 4 times 3. What will be 4 times 3? 4 into 3, 4, 4, 8, and then 12. So this will be the negative 12 x, then 4 minus 1. And then the last one will be what? Because there is a 1 here, it will be plus 8x 1 minus 1. And then the final answer will be 10x to the exponent 4 minus 12 to the exponent 3, or x to the exponent 3. And then this one will be equal to 0. So anything that equals 0 will give us the plus of 8 times x, which is 1, right? And then anything, or 8 times 1 will give us an 8. So the entire equation here will be correct, and you are going to get your marks. So this is actually the entire expression. There is no need for the multiplication of 1 here, because this will never change anything. So the final equation will definitely be something like this. So 3 marks it is, and then you do have your marks there. So since we are busy dealing with the derivation, we have another one that says that the tangent to g of x, as you are given your equation, has a minimum gradient at the point for which x will g function be concave up, positive. Okay, so this means that in order for us to get, as they said, for which values of x will g be concave, I mean, now starting to jump, so concave up. So this means that we want, the positive side of this, and we have to deal with the tangent. So sometimes when a graph intersect with an angle, I mean with a circle, you'll find out that they call this particular point here a tangent. So then they will use some angles to be able to see what the radius is, blah blah. So we'll get to this point when we get to paper 2, but this is not actually the time for the explanation about paper 2. But the only thing that I can actually tell you to do is to get, or go there and find the g of x, right? You continue to g of x as 1 prime, and then the second prime. Drive the equation twice and then substitute the value for x, because you don't have other values, and substitute the value that you have, and then you'll get what you are actually looking for in terms of the concave up for the g of x. So now I will just say, okay, the first derivative of this will be what? 3. Now you know how to write it. This times this, 3ax, then 2, no longer 3. The plus of 2 times 3, that will be a 6, then x. And then what about this? We have 1x, it means 1 into this, the plus of b. So a constant will always be 0. So if you have an equation that says x squared plus 2x, the plus of 1, f of x, if you drive this like one time, you are going to get 2, sorry with the color, that color is okay, 2x, then the plus of 2. This one will always be 0 because it's a constant, can't drive it. Okay, so now let me continue with what we are busy with, which is the business of the day. So b, this is actually our first derivative, and then we go to the second one. This times this 6, all right, and then ax, then this one will be minus 1, then will be 1, so can't put it there. The plus of 6, because this times 1 times 6 will be 6, and then minus 1, this one will be 0, and then x to the exponent 0 will give us a 1, so which is useless to place there. So it means that now we have g, and then drive twice, and this is the function that we do have. So now you are going to say g, and then you have your negative of g of -1 is equals to, you are substituting, you know, the -1, 6a is to -1, the plus of 6 is equals to 0. Let me continue up here. So you have 6a, the, you know, -1, and then let's take this to the other side, which is equals to -6, right? So this means that you have -6a, which is equals to -6. You divide it by -6, this by -6, this will be positive, this will be cancelled. Okay, this will be cancelled. So meaning that a is equals to 1. So you do have the value which is 1. Perfect, perfect, perfect. So if the value is 1, now you know that this equation here should be g, okay, as it is, the way it is, of x concave up, it should be greater than 0. So now you have 6x plus 6 greater than 0. Remember, the reason why I have 6x plus 6 is because I substituted a here. A is 1, so it does not actually change our equation, but it was removed. So meaning that now this should be what? This should be maybe all divided by 6. So if we divide everything by 6, this will be x plus 1 greater than 0, and then the final answer will be x greater than -1. This is the final answer. I don't actually have enough board, but I can go back and say 6x, the plus of 6 is equals to 0, and you know that 6x is equals to -6. So when you divide this, you are going to get a -1. But remember, since we are dealing with the concave up, then we have to look for g, drive twice of x greater than 0, meaning that we don't have to use an equal sign here. Now the equal sign will be replaced by the greater sign, which is greater than 0, and then greater than -6. And if you divide this by 6, then you cancel everything, and you know that your x will be greater than -1. So this is the, you know, the value of x that they were looking for in this particular question. So yeah, I hope that you do understand. If you don't understand, please comment. I'll come back and, you know, give you another example based on this. Thank you guys. Thank you.